Dear students, MDCAT ECAT test is conducted every year for the admissions in MBBS, BDS and engineering degree programs. MDCAT test is computer-based MCQs test. These MCQs are usually easy but have tricks to solve it. The purpose of these videos to make you understand these tricks. Students, MDCAT और ECAT टेस्ट हर साल MBBS, BDS और इंजीनियरिंग डिग्री प्रोग्राम्स के एडमिशन के लिए लिया जाता है। यह टेस्ट कंप्यूटर बेस्ड MCQs पर मुश्तमिल होता है। इस टेस्ट के MCQs आसान होते हैं, लेकिन इन MCQs में छोटे छोटे ट्रिक्स ज़रूर होते हैं। इन वीडियोस का मकसद आपको वो ट्रिक्स समझाना है ताकि आपकी अच्छी प्रैक्टिस हो जाए। Okay, MCQs number 1 is how many molecules are present in 0.2 gram of hydrogen gas? Option A is Avogadro number Na. Option B is 6.023 exponential 22. Option C is 2 multiplied by Avogadro number. And option D is 3.01 exponential 22. To solve this MCQs, you know that molecular mass of hydrogen gas is 2 AMU. So 1 mole of hydrogen gas will be 2 grams. 2 grams. 1 mole contains Avogadro number of molecules, 6.023 exponential 23 molecules. Now, from 2 grams, you are given 0.2 grams. 0.2 grams. So, they have divided 2 grams on 10. So, you also divide Avogadro number of molecules on 10. When you divide the Avogadro numbers on 10, it will become 6.02 exponential 22 molecules. So the answer is 6.02 exponential 22, mean option B is correct. MCQs number 2 is which one of the following gases will have the highest rate of diffusion? Option A is CH4, option B is NH3, option C is N2 and option D is CO2. To solve this MCQs, you know that the rate of diffusion of the gases is inversely proportional to the square root of their molecular masses. It means the smaller the molecular mass, the higher will be the rate of diffusion. Now find the molecular mass of these gases. Molecular mass of CH4 is 16 mu. Molecular mass of NH3 is 17 mu. Molecular mass of N2 is 28 mu. And molecular mass of CO2 is 44 mu. So the correct option is CH4 because the molecular mass of CH4 is the smallest in all of these gases. MCQs number 3 is the density of gas does not depend upon. Option A is pressure, option B is molecular mass, option C is temperature, and option D is depends upon all. To solve this MCQs, you know that density is equal to mass upon volume. Mass is directly proportional to density and volume is inversely proportional to density. You also know that Volume depends on temperature and pressure. Volume is directly proportional to temperature and volume is inversely proportional to pressure. So, density depends on mass, density depends on temperature, density depends on pressure. So, the correct option is depends upon all. Option D is the correct option. MCQs number 4 is the volume of an ideal gas is reduced to half its original volume. The density of the gas, option A remains the same. Option B is halved. Option C is doubled, and option D is tripled. To solve this MCQs, you know that density is inversely proportional to volume. If volume is reduced to half, the density will increases to doubled. So the correct option is C. The density will becomes doubled. MCQs number 5 is at constant temperature the pressure of the gas is reduced to 1/3 the volume. Option A reduces to 1/3. Option B increases by 3 times. Option C remains the same. And option D cannot be predicted. To solve this MCQs, from the first sentence, at constant temperature. When the temperature is constant, you should click. It is Boyle's law. In Boyle's law, the temperature remains constant. In Boyle's law, we know that volume is inversely proportional to pressure. If the temperature of a gas is reduced 3 times, the volume will increase 3 times. So, option B is correct. Option B is increases by 3 times. Next MCQs is the partial pressure of hydrogen in a mixture of 50 gram of hydrogen gas and 50 gram of helium gas if the total pressure of the mixture is 1.5 atm. Option A is 1.5 atm. Option B is 1 atm. Option C is 0.5 atm. And option D is 2.5 atm. To solve this MCQs, you know that partial pressure is directly proportional to number of moles. So first find the number of moles of hydrogen gas and helium gas. Moles of hydrogens are 50 divided by 2. So 25 are the number of moles of hydrogen gas. Moles of helium, 50 grams divided by 4. 4 is the atomic mass of helium. So number of moles of heliums are 12.5. As the number of moles of hydrogen gas are doubled as compared to the number of moles of helium, so the partial pressure of hydrogen will be doubled as compared to helium gas. So the total pressure is 1.5 atmosphere. The partial pressure of hydrogen will be 1 atmosphere and the partial pressure of helium gas will be 0.5 atmosphere. The partial pressure of hydrogen will be doubled as compared to the partial pressure of helium gas because the number of mole of hydrogens are doubled as compared to the number of moles of helium gas. So the correct option is 1 atm because you have asked the partial pressure of hydrogen gas. MCQs number 7 is the gas which cannot be liquefied. Option A is H2S, option B is CO2, option C is nitrogen, and option D is ideal gas. To solve this MCQs, you know that ideal gases have no force of attraction and it cannot be liquefied, while real gases mean non-ideal gases have forces of attraction and hence can be liquefied. So the correct option is D, which is ideal gas. MCQs number 8 is at constant temperature for a given mass of a gas, the product of pressure and volume is constant. It is the statement of Dalton's law. Option B is Boyle's law. Option C is Charles' law. And option D is none of these. Again, from the first statement, at constant temperature, you should know, you should click at that it is Boyle's law because the temperature remains constant. When temperature is constant, it means it is Boyle's law. Mathematically, Boyle's law is PV is equal to constant, mean product of pressure and volume is always constant at constant temperature. So the correct option is Boyle's law, option B. MCQs number 9 is the non-ideal behavior results chiefly from option A is intermolecular attraction and infinite volume. Option B is elastic collisions and finite volume. Option C is intermolecular attractions and finite volume. Option D is intermolecular attractions only. To solve this MCQs, you know that non-ideal behavior is due to the two faulty assumptions of kinetic molecular theory. The first assumption is there are no attractive forces between the gas molecules. The second assumption is the actual volume of the gas molecules is negligible as compared to the total volume of the gas. These are the two faulty assumptions of kinetic molecular theory which were get corrected by van der Waals. So the correct option is option C, intermolecular forces and finite volume. MCQs number 10 is ideal behavior of a gas is most likely to be observed at option A is positive temperature and high pressure. Option B is negative temperature and high pressure. Option C is positive temperature and low pressure. Option D is negative temperature and low pressure. To solve this MCQs, you know that gases will be more ideal at when there is no attractive forces between the gas molecules. There will be no attractive forces when their volume is large. When the volume of the gas is large, there will be no attractive forces. The volume will be large at low pressure and high temperature. The volume will be large at low pressure and high temperature. Mean at low pressure and high temperature, the gas molecules will be far away from each other and there will be no attractive force, and hence the gas will be ideal gas. So the correct answer is Option C, positive temperature and low pressure. At positive temperature and low pressure, the volume will be large, the gas molecules will be far away from each other, and there will be no attractive forces, and hence the gas will behave ideally. MCQs number 11 is a bottle of dry NH3 and a bottle of dry HCl connected through a long tube are opened simultaneously at both the ends. The white NH4 seal ring formed will be option A is at the center of the tube, option B is near the NH3 bottle, option C is near the HCl bottle, option D is throughout the length of the tube. To solve this MCQs, you should know Graham's law of diffusion. The rate of diffusion is high when the molecular mass is less. The molecular mass of NH3 is 17, while the molecular mass of HCl is 36.5. So, the rate of diffusion of NH3 will be very fast as compared to that of HCl gas. So, NH3 molecules will cover more distance than that of HCl molecules. So, the reaction will take place near the HCl bottle and NH4Cl will formed near the HCl bottle side. So, the correct option is option C, near the HCl bottle side. MCQs number 12 is a mixture contains 2 moles of each hydrogen gas, helium gas and nitrogen gas. The ratio of their partial pressure is respectively option A is 1 is to 1 is to 1, option B is 1 is to 2 is to 2, option C is 1 is to 2 is to 14, and option D is 2 is to 3 is to 6. To solve this MCQs, you should know partial pressure is directly proportional to number of moles. If the number of moles are same, then partial pressure will also be same. In this question, you are given 2 moles of each hydrogen, helium and nitrogen. It means the number of moles are same, then the partial pressure will also be same. So the correct option is option A, 1 is to 1 is to 1 will be the partial pressure of all the 3 gases. MCQs number 13 is which one is the combination of 3 gas laws? Option A is equation of state, option B is ideal gas equation, option C is universal gas law, and option D is all of them. Equation of state or ideal gas equation or universal gas law is same. We know that PV is equal to nRT is the combination of 3 laws: Boyle's law, Charles law and Avogadro law. This equation is called ideal gas equation or equation of state or universal gas law. So the correct option is option D, all of them. MCQs number 14 is the pair of gases for which Dalton's law of partial pressure is not applicable. Option A is nitrogen and oxygen gas. Option B is hydrogen and nitrogen gas. Option C is carbon dioxide and nitrogen gas. Option D is NH3 and HCl gas. To solve this MCQs, you should know that Dalton's law is applicable only for those gases which do not react with each other. If the gases react with each other, then Dalton's law of partial pressure will not be applicable. NH3 and HCl reacts with each other and form NH4Cl. So Dalton's law is not applicable for these two gases. So the correct option for this MCQs is option D, NH3 and HCl. It means for these two gases, Dalton's law is not applicable. MCQs number 15 is, out of the following pairs of gases, which will diffuse through a porous plug with the same rate of diffusion? Option A is NO and CO. Option B is CH4 and O2. Option C is NO2 and CO2. Option D is NO and C2H6. To solve this MCQs, you must know that gases having equal molecular masses will have the same rate of diffusion. Mean if the molecular mass of two gases is equal, then their rate of diffusion will also be same or equal. So first you find the molecular masses of all of these gases, then you will know that option D is the correct option, because the molecular mass of NO is 30, 14 plus 16. 14 is the molecular mass of nitrogen, atomic mass of nitrogen, and 16 is the atomic mass of oxygen. So 30 is the molecular mass of NO. Similarly, 30 is the molecular mass of C2H6. So option D is correct. Thank you for watching this lecture. Hope you will like the lecture. Thank you.